So I want to talk about a couple problems with designing drones to help fight wildfires and other natural disasters and ways around them. One is that heat from fires can cause very uneven winds, winds going up, and they can also cause winds going side to side as air flows to fill in the gaps like convection currents. It can cause the air to have different density, so hot air has a lower density than cold air, but also smoke has a higher density than regular air. And that can affect flight because if you have a higher density, sometimes suddenly you have more air friction, but you also have more thrust. That can really impact the dynamics. So you have all that huge problems occurring right there. There is some ways though around these problems. One is to design a vehicle that's more inherently stable itself, and you can do this with having multiple more distributed ways of thrust or lift. So not only one section has thrust or lift generating, so it's less sensitive environment, making sure that it's more stable with its weight distribution. Another thing you can do is have it automatically detect when it starts getting unbalanced and rebalance itself using adaptive motor controls and stuff like that. But you can also, to some extent, sense the differences in different types of smoke and stuff. And the way you can kind of sense the differences in the different types of smoke and stuff is with such methods as some cameras can see density differences in air slightly because denser air refracts light more than light air back and forth, and that's just the phenomenon that can make mirages and stuff. Because the hot air is less dense and bends light. When light hits it, it bends, creating a secondary image. So you have technology like that, but even though the sensors can be simple to super expensive, it requires a lot of computation powers and expertise there. Not impossible, but will require a lot of innovation there. Another one is LiDAR or something, which is where we use lasers and stuff to map out a scene. You can make excellent 3D renders where you just shoot out a bunch of laser beams and measure how they come back. LiDAR can also be refracted and by air in different ways and measure how the density of air and the other properties. You can have infrared cameras that measure heat given off, even though infrared cameras are now a lot more expensive. We are doing a lot of things to make them much more cheap. So they are coming down in price. But all this technology was probably better if we include them all together with a very good software that will take a long time to develop because we have to really develop it with a lot of data sets in a variety of conditions, especially if we're using machine learning. Because machine learning requires a lot of data. The way around machine learning is that we run also a bunch of simulations, but the simulations are not the most accurate and best. So in reality, we probably have to do both or use the simulations to add on extra data to the machine learning and to keep the machine learning a little more grounded in reality so it doesn't do crazy predictions and just finds a correlation that's not random and just keeps going on and on with it. Another thing we could do is other sensors is air quality sensors to get a little feel for the air, or sound sensors. Echolocation might work because air again refracts sound waves differently depending on how dense, and the speed of sound is different depending on density. So echolocation might work partly with this technology, and the compressor and decompressor can exaggerate differences in density of air, making the other instruments more sensitive. But you could also have just listening to sound on itself, and machine learning just also to learn not what is actually hotter or colder or something like that, or more dense or less dense, but get a general feel of what should be, so more of like a common sense. Another problem is dust. Dust is a huge problem because it can get, with number one, some of the stuff with density also applies in really bad weather conditions with rain and stuff like that can knock it off, something off track, or cause it problems flying. Dust. Dust is a huge problem, and this one you would have to rework on designing better motors because a lot of things could get potentially trapped in the motors or in the moving parts and really free them up. So you have to either have large gaps that dust doesn't really bother you, or you have to have something it's sealed so dust really cannot get in. Then you also have to worry that some dust is electrostatic, meaning that it gets static charges, and that can stick stuff together like a balloon on people's hair when you rub it, which can also shoot out electronics. All this is stuff that's possible to work around, but you have to think about it more directly. It can also change the thrust profile again, not as major in most cases unless there's a real ton of dust, but you have to look at number one for that. So dust we have to think about. Also with machine learning and sensors, everything that could help also avoid dust or at least make it adapt or expect the dust again better. So kind of both. Dust is also actually, I think now that I think about it, more similar to rain and stuff with hitting it, or snow or something like that with the bad weather conditions, if you were to compare it to other problematic weather conditions. Another huge problem with all this is smoke. Smoke has many problems in that it can really mess up your sensors. Having sensors that look at a broad range of wavelengths and certain wavelengths can help get around this, but that tends to be more expensive, even though we are rapidly getting down in price. Another one is dust can get in it, the sensors, or block some of the sensors. Another problem with sensors is that heat can also disrupt a lot of the more sensitive ones because they need to be cooled. They're getting better and better away from that. So I don't think that's going to be major problems, and you probably don't always need the most high-tech sensor resolution-wise. It's probably better to see more different variety of colors and higher resolution to some extent, because you don't need the highest resolution to actually navigate and identify people and stuff. But dust and stuff can still coat it, so you have to think about lens and optics that get less coated by dust, get less interfered by dust, or something along that line. Not only is the interference part of it important, but if it's not only about less coated, it could also be have something to help clear out the lenses themselves, or so maybe something that scrapes it or cleans off with some water or something to do it so it's not always the most dirty it can be. You could also maybe vibrate it to help get some stuff off. Have backup or mobile sensors in case one gets dirty, so you have clean it up. You can move the sensor around on a scanning beam so it takes off a little more. Maybe that will help a little bit. Maybe you also have it that some dust doesn't absorb as many wavelengths as other dust, so having again a sensor that uses mobile wavelengths could work better. Also, dust might not interfere as much with like echolocation or other sensor instruments. So all this stuff you have to think about, but it probably is doable if you put a lot of effort into thinking about how everything impacts each other's and works together. A lesser problem is how you communicate back and forth with this stuff. And that's because radio transmission is not always the best in some of these environments, because you have a lot more things that might interfere, especially if you're in a house. In a house, you might have walls and stuff like that, or a collapsing building or something that might all interfere with it. The ways around, then radio also with the air having different densities, it can bend the radio waves in different ways. The way around this is if radio waves do not transmit as fast, well, you can slow down the speed and get higher accuracy by repeating the message or something, so the interference is not as, and noise is not as big a deal. It's the same idea that if you can't hear someone clearly, they might repeat themselves a couple times until you get the message across. But that comes down slow. You could have multiple drones flying together, or other ones together that they all transmit data back and forth to themselves. You could have it that some artificial intelligence involved, so they need to transmit less data. And they can make more decisions on their own, or you can use artificial intelligence actually to compress the data better, which I've talked about before. You can also use alternative ways of communicating with like more visible light or other light waves, or which you can actually incorporate in the LiDAR instruments, can also be used for really high speed transmitting data much faster than radio waves between 2 points, but you have to really accurately line it up. And echolocation can transmit data more slowly, but through more medium. A problem though with echolocation I forgot to mention before is that echolocation is more sensitive to other drones interfering with it. Another problem with all these drone ideas is that they blow air downwards. This blowing air downwards can cause significant problems because it can spread out air, it can spread out dust and smoke. Now, a person moving can also do this. This is not as big of a problem if it's in the middle of a big wildfire or something, where it's always going to spread the fire into fire. The more distributed the propulsion is over the whole thing, the less of a problem it is. The smaller it is, the less of a problem it is. The more it can adapt to like needing less thrust when it has heat that's rising up and floating along, so it doesn't need to push down as much, the less of a problem is. So, and also sometimes you could design some of this to push air in certain ways that might even help extinguish it. So that certain ultrasonic waves can help extinguish fire, but pumping more less oxygen in a certain area with certain thrusters, but that's way more complicated and harder to do. It might be a lot of times impossible. A final note / idea kind of for here that I forgot to mention, but is really important, is why not fly at all, just have a ground vehicle. Now, a ground vehicle, the problem is that it has to handle a very wide range of terrain, which is really hard. There could be a ton of obstacles, which could also significantly slow it down because it's going along the obstacles and has to go up and down and stuff like that instead of just flying straight. So that's that huge problem with it. Now, you could also try to devise a hybrid vehicle that works on the ground, can fly, and can move on the ground. So the best of both worlds. And that could have many advantages. Also, a ground vehicle can take more weight. That could have many advantages, but it's a little more complicated design. You might argue it's simpler because you can make each function simpler and don't have to worry about all the special scenarios by just switching between one or the other one that works the best for each scenario. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but with your help, I think can do it. Also, if any ideas for future videos, comments, or suggestions, please leave in the comment section below. Again, thank you very much. Goodbye.